Hello, dear students. Welcome back again to study a new section about physics grade 10 English system. Students, the previous video already we finished section 2 all, and we solved it, we explained, we did most of the example, most of the topic. Now we have a new section, the last section of this chapter 3, section 3 and chapter 3, which is called fluids in motion. Fluids in motion. Students, this topic we're gonna explain inshallah about a study examine the motion of the fluid and using continuity equation. We'll study inshallah. We have some type of flowing or some type of moving or speed of the motion. We have some types we can say we have two types of moving water. Inshallah, now in detail we'll explain about this topic. Students, the first section in the book, this page it's explaining it by the complicated way. Actually, I summarize for you by I summarize for you in a table in here. Look, I make a table for you to separate both of the types. So this topic you can immediately cross out. You can directly understand this page because I summarize for you all. Students, we have fluids flow. What is the meaning of fluids flow? We have fluids, for example, anything. For example, water. The water is moving. The water is moving in two different way, or we can classify the moving fluids in two different way. When a fluid, such a river, water is in motion. When the fluid is in motion, this flow or the flow can be classified in one of two ways. The fluids of the water, the fluid of any type of the fluid, liquid or water, anything, can be classified in two ways. The first called laminar flow or regular flow, and the second, the second type of the moving water is called a turbulent flow or irregular flow. Students, look, we have two types of moving fluid, or the fluids can flowing or can classified in two different types. First one, laminar flow or regular flow. The second one, turbulent flow or irregular flow. Let's talk about the first type. The first type of moving fluid or moving waters. Students, first type, it's written laminar flow. The motion of the particle as smooth path traveled by the particle. It's look like a parallel line and it's called streamline. What that mean? Students, look at this picture. This is a river where the water is moving. Look, this actually, we throw a cylinder. We already throw a cylinder inside the water. Around this cylinder, some of the water is moving regularly, some of them is irregularly. Sorry, look. Look, this region, it's called laminar flow. Laminar flow, it means regular flow. The moving of the water regular. It's not randomly. They are moving regular. It means the water direction, they are moving in a straight line. The water direction, straight line, and regularly, not randomly. Look, how we know that, mister? Look, in this region, as I told you, it's laminar flow, regular flowing. Look, this color, this is the water direction, both of them same direction. Look, the water is moving in the same direction. This white color. Look, all they are moving in the same direction. So this called laminar. This one too. All they are moving same direction. This is called laminar or regular. And even in math, you studied if we have two same direction lines, these two directions lines, they never cross each other, they never intersect, they never cross each other. These two lines called parallel line. So for example, I'm going to take these two lines. These two lines are in opposite to each other, in front of to each other, and they never intersect. So these two lines, it's called parallel line. So that's why in here it's written, in here the motion of the particle, smooth path traveled by the particle, it looks like parallel line. This line, now mentioned the direction of the moving particle, it was like that. Look, so these two lines, because two lines opposite, they never intersect. These two lines called parallel lines. So laminar flow, regular flow, the direction of the moving particle, the motion of the particle, the direction of the moving particle is smooth, and it's look like a parallel line because the two lines are never intersect. Look, it's like a parallel line. And the name of each line, this line has a different name, the new name. This line is called streamline. Each one of them is called streamline. So these two streamlines called parallel line. So the first property, laminar flow, the direction, look, parallel direction, they are straight line. They never intersect. Look, they are straight line. They're straight line. It's not randomly. They are moving in a straight line. So this is called parallel line, and the direction of the moving water is straight line, and the two lines because never intersect, so this is called parallel line. This is the first property of the laminar flow or regular flow. The second property, different streamlines cannot cross each other. Now even we said same thing, it's written, it's not new, because we said the direction of the moving water, both of them, it's like that. It's parallel. So these two lines, they never intersect. They are going straight line. They never intersect. We say that different streamline cannot cross each other. They never intersect because it's parallel line. Because it's regular. They are going in the same direction. Okay, this is about the second property. The third property, no obstacles or sharp turns in the way of the fluid. This is important, students, to understand what the meaning of this, the third property. No obstacles or sharp turns in the way of fluids. What is the reason why the waters are moving in the same direction regularly, straight line? Why they are not moving, or they're not flowing randomly or irregularly? Why? What is the reason? The main important reason is this. The main important reasons, for example, look, the waters are moving in this direction because no object or nothing comes on the way in here. Like there's nothing comes on their way. That's why they are going in the straight line. Nothing comes on the way. No object, no ship, or for example, no rock. In front of the water is empty. Nothing comes on the way. That's why the waters can moving same direction, straight line, so no obstacles. So this is the reason. That's why even look, nothing is in here on the way. Look, nothing comes on the way. It's smooth, no ship, no rock, nothing. That's why the particle or the direction of the water is straight line. No obstacle or no ship, no object, no rocks. There's the direction of the water is straight line. This is the reason. The last property, the velocity. This is about velocity or the speed, or velocity or speed, both. It occurs when the fluids flow slowly. They are moving slowly, not quickly, and the speed. So this fourth property, I'm going to repeat again. First, the motion of the particle smooth, and it's two lines opposite to each other. It's parallel lines because they never intersect, and the name of each line, it's called streamline. Look again. Two lines, they never intersect. So this is called regular flowing, straight line. They are moving irregular. The second property, different streamline different streamline cannot cross. Of course, cannot cross each other. Look, they never intersect. Look, only two same directions, so they never cross, they never intersect. Property number 3 is so important. Nothing comes on the way. There is no object cut, there is no sheet, there is no rock. There is no object cut. That's why they are going in the same direction without changing the direction. This is the reason. And the last property there, the velocity or the speed slowly. Guys, imagine, for example, wait a minute, concerning property number 3. Imagine the directions is the water is moving like that, straight line. Imagine I'm going to throw a rock or something's inside the water. For example, I'm going to throw the rock and the rock comes here. Immediately the direction of the water, they have to change the direction. Because why? Because I throw the rock inside the water. There's some things on the way. There's obstacle. There's something turns to the way the water. To the water, they have to change the directions. So in that case, the water change the directions, become irregularly. So they intersect in this case. They intersect because I throw something, but actually there's nothing on the way. That's why it's no obstacle. Okay, imagine I said if you like to throw something, what's gonna be happen at the end? They'll change the direction because something comes on the way. But in this property, no obstacles. So laminar flowing, the first property, the motion of the particle is smooth particle and streamline or parallel. Rule number 2, different streamline cannot cross each other. Rule number 3, nothing comes on the way, no obstacles. And rule number 4, the speed or velocity slowly. We have the second type of the moving water, which is called turbulent flow or irregular flow. Students, what we have studied in here in the first type, directly you can make it opposite. Same thing, but make it opposite. How, mister? For example, turbulent flow, by the name you can understand, it's written irregular flowing. Irregular flowing. It means the direction moving of the water in this type is not straight line. It's different. It's different than the first type, regular. In regular, we said a straight line or parallel line. No, in this type, no, it's not a straight line. So what is in here? The motion of the particle, it's circular now, So important, be careful. The main point different between regular flow and irregular flow, only about in regular flow the direction is straight line, but in turbulent or irregular flow it's circular path. Why circular path, mister? Because look, we have in here, for example, I throw a section of cylinder, any object, I throw this section cylinder inside the water. During when I'm gonna throw this, look what's happened around the water, around this river. Look, the shaping of the water has become changed. It's become like a circle. Look, it's become change the shape because we are throwing something. Look, it's not like a straight line. Look, it's become like a circular part. It's written turbulent flow or irregular flow. Why it's become like that? Because we are throwing this section, this object inside the water. Of course, the shape of the water immediately become deformed or become changed. So the reason that, for example, you want to throw something, throwing something or something's come on the way, the shape of the water become deformed or become changed. So looking in that case, the water shape become like a circular path, because we are throwing this section of the cylinder. So now we understand the reason that becomes circular path, because we throw something. Look, the motion of the particle is circular path. It's called eddy current that appear. What is the reason behind this? Why it's become circular path? The things behind this, obstacle, now even we say obstacle, yani something comes on the way, something, or for example, you are throwing something, now even here I mentioned it, we throw this section of the cylinder. That's why it's become a circular path. Look, or for example, the water is moving in this direction. There's an object in here. Immediately they are changing their direction like that. Become a circular path. So in general, if any obstacle, any object comes on the way, they are changing their direction. So the first property, the motion of the particles, circular path, and the reason behind this because there is obstacles. The second property, different streamline now in here can cross each other. Yeah, they have to cross each other, of course. Why, mister? Now look, the shape of the water is circle. Of course, it's become circle like that, huh? Of course, they are crossing each other, huh? Because after when we are throwing something, the waters or the line, they can cross each other. Rule number 3. Of course, even now we said, all now I explain it. Existing obstacle, of course, something, you are throwing something comes straight on the way, existing something, object or sharp strand in the way. The last property, it occurs when the fluid flows quickly. So we have two types of moving water. First, laminar, regular, or the second, turbulent. So this is turbulent, irregular, huh? The shape has become a circle, but that one, look, is parallel line, is laminar, but that one turbulent is circle. So look, even in the picture you can understand. That one, it's a regular, laminar, because the two lines parallel and straight line. There's nothing on the way, it's come on the way. But that one is turbulent, irregular. Why? Because we are throwing this cylinder, sorry, and the shape is become a circular part. Look. Okay. Students, we have another topic which is called the ideal fluid. We finished now the fluids flowing. There was two types of fluids, regular and irregular. We explained all. The second topic on this page, which is called ideal fluids. What is ideal fluid? Guys, in physics or in chemistry, in any topic, if you hear this name, if you hear this word, ideal, that means all things, any things that we have, it's constant or stable. Like we cannot change the value of the quantity. Because ideal means stable or constant. Same meaning. Constant, stable, we cannot change the value. This is the meaning. So, the definition of ideal fluid, it's a type of the fluid, a fluid that has no internal friction or viscosity and incompressible. Look, now I told you, even by the name, because it's ideal, all the things that we have, it's stable. We cannot change it. For example, there's no internal friction. You know the meaning of friction. For example, friction between two objects is going to be happen. For example, the earth with the cars of the wheel. When the wheel of the car is spinning around the earth, the cars with the earth they have a friction. So between the layer of the fluid, or between the particle of the fluid, between the layer of the fluid, there is no friction because we have ideal, no friction or viscosity or is incompressible. Yani all things that we have, it's stable or constant, or we don't have it, we can say like that. No internal, no viscosity, or no incompressible. No compressible or incompressible. We have some property of ideal fluid. First property, non-viscous. Guys, all is about non or incompressible. Non-viscous, incompressible, velocity, density, pressure, no change. Constant, no kinetic energy. Yani we have all this none, because we have ideal. The property of ideal fluid. First, non-viscous. First, let me tell you what the meaning of viscosity. Students, look at this two picture. We have two containers. both of them is liquid, but I don't know which type of the liquid. Maybe this is mercury. This is not important. Just I would like to understand what is the meaning of viscosity. Students, inside this two container, we have two different type of the liquid. We would like to flow this. We would like to flow or transfer this liquid from this container to another container, or the same thing. Flowing from this container to another. Focus on thing. Look, this type of the fluid, when we would like to flow this, it take less time to all the liquids comes out to this container, or it take less time to flow out this liquid. But that one no need time is maybe it needs 1 hour to the whole type of the liquids to come to the second container. But that one no maybe it takes 10 minutes. The whole type of liquids come to the second container. What is the reason? The reason is this type of the liquid has more viscosity, but that one, oh sorry, I mix it. No, that one has less viscosity, but that one has more viscosity. Why these liquids take 1 hour to flow? For example, this time is not right. I said, for example, if it needs 2 minutes time, for example, it take 1 hour to this type of liquids comes out. Why? because this type of the liquid has more viscosity. Viscosity, it means there's internal friction between the particle or between the layers of the liquid. There is more friction. There is more friction. So this type of the liquid needs times to comes out. But that one, between the particle or between the layer of the liquid, there is, for example, in here between the layer of the liquid, there is a few or there is a less viscosity. That's why immediately it comes out. Or guys, you can make a difference between water and honey. And you look, water immediately, it take 1 second, all the water comes out, but honey take time. What is the reason again? Because the honey has more viscosity, but water has less viscosity. So viscosity, the friction between the layer of the particle. If they have more internal friction, the type of the liquid need more time to comes out. So in here, look, I just would like to understand what the meaning of viscosity. So non-viscose, there is no internal friction between the layer, huh? So ideal fluid, there is no viscosity. Incompressible, and even the velocity, density, pressure, all is constant. We said why? Because it's ideal and stable. Ideal fluid, moving of ideal fluid. Which type now we studied? We studied two types of the moving water, moving fluid. Laminar or irregular and regular. Ideal fluid, which one of them? Ideal fluid moves in a laminar, regular. Rule number 5 or property number 5, no kinetic energy loss due to friction. So in general, all of them is stable, non-viscose, incompressible, no kinetic energy, velocity, density, all constants. Okay. Students, another part you have principle, the principle of the fluid's flow. We understand now the fluids flowing in characterized in two ways. We said irregular and regular, and even we explain all the property. But now we want to understand according to which principle the fluid, the waters can move, according to which rules. Students, dear students, we have a rules which is called continuity equation. Continuity equation this page, guys, in here we have proving. So this proving is not important, only we need the rule that were important. Continuity equation, we have this rule: area 1 times speed 1 equal to area 2 times speed 2. Let me tell you what the meaning of this. Students, area 1 v1, it means in the first region we have velocity. In that region, in the first region, we have area, and in this area we have a velocity. In the second region we have a second velocity. You can understand in this picture. Look, we have this pipe. We have this pipe. Inside this pipe, some water or fluids goes inside the water. So we have two different regions. We have two regions. The first region, this first region, so it's called area 1 or velocity 1, first region, and that one is the second region, area 2 or velocity 2. So guys, we know that when the fluids goes inside the pipe, of course they have a velocity. Fluid or water inside the pipes moving, they have a velocity. We want to understand in both regions that they have the same velocity, or the velocities can change, or for both of the region has same velocity, or the velocity become changed for each region. Actually, the velocities become change, not same. Why? Students, the relation between area and velocity inversely proportional. What that mean? Even when we studied the previous lesson, you have to know. Inversely proportional, it means one of them increase, the other decrease. For example, if we have more area, that means we get small velocity. Or if we have a small area, we get large velocity. So the relation between area and velocity inversely proportional. For example, you have a small cross section of the area, and the water goes inside this small cross section of the area. How is the velocity of the water? Is it large or small? Of course it's large, because we have a small cross section. Of course, at the end we get a large velocity. So the relation between velocity and area inversely proportional. So look at this picture. In here, look, focus, we have compare these two regions. Which one of them has small cross section or small area? Of course that one, You have small area, you have small area. Of course, in this region we have more velocity. What about in the second region? In the second region, no, in here comparing with the previous one, in here we have a large area. Because you have a very large area, when the water in here comes out, the velocity of the water is small, because we have a large cross section, and we get small or less velocity. So this is important to understand, only this in brief. Even I wrote a note for you, This equations means that the fluid's speed v faster where the pipe is narrow. Faster, narrow, it means the area is small. We have small area. Where the pipe, the area it's narrow, we get a faster velocity. We have a narrow area, we get a large velocity. And slower means when the velocity becomes slower. When the velocities become slower, where the pipe is wide, it means we have more area. So velocity in a pipe inversely proportional with the area on the pipe. Guys, you have another example about this relation. The speed or fluid flow depends on the cross-section area. the speed when the speed's moving depend on the section area. Guys, look at this picture. This picture is important, good to understand. For example, your mom's she's washing, for example, your home, or for example, your dad's washing he's washing your the cars, for example. You're gonna use this thing is to wash anything. Have you noticed that even your mom, when she gonna wash anything or clean anything, she will put her thumb on this cross section area, right? When she'll put her thumb on this cross section area, this, for example, look, this is the section of the area. You will gonna put your thumb, for example, in here, right? This is your thumb in here, right? Okay, so the area is become small. This is the first area. After this is your thumb, less areas left. We have less area, so the areas become less. That means more waters comes out. The velocity become large. Even look, the waters look so fast, quickly it comes out. So that means because we put our thumbs on this cross section, we get less area. At the end, we get a large velocity, a large speed. And here it's written, your thumb reduce the area of the opening and increase the speed of the water. Okay, students, this lesson's enough today. I hope to understand what you have already studied now. Thank you for watching my video. Thank you for all. Have a nice day.